Welcome back, Math 9. We are back on online. And what we're going to start with is linear inequality. It is different type of equation that you have been dealing with, except inequality deal with anything but our equal sign. So what I mean by that, there are four types of symbols that you need to be familiar with. Let's say we have our unknown variable on the right side, then you can interpret the symbol between the constant value and the variable. So if you look at the first case, you will notice that the alligator mouth I like to call is open to the left, not on the right. So you can say it is whatever the constant value on the left side smaller than that. If you have alligator mouth on the left and one line below, it's smaller or equal. If, on the other hand, the alligator mouth is pointing toward x, you like to say bigger than. If it has alligator mouth toward x and a line below, you can conclude that this is bigger than or equal to. Fortunately, this symbol should not be new to you. Now, then let's go through. Then let's go through this. Can we write inequality for each situation? Let's look at case by case. Speed limit 55. Generally, it's kilometer per hour, so let's assume that unit. Well, in that case, you should drive 55 smaller or equal to, I like to say, in order to avoid any ticketing, right? 55 kilometer per hour is your speed limit, or it can be mile per hour, but in any case. Height restriction, you must be at least 1 or 2 centimeter to go on this ride. So that means 102 centimeter. I forgot the unit in here, by the way. Sorry about that. And x should be bigger or equal to. That's what at least means. Third situation, store at temperature below 4 degrees Celsius. The term below means, first of a unit, it should be something other than 4. Probably 3.9, 3.8, all the way below. Or if it's integer, countable number, 3, 2, 1, 0, -1, -2, those kind of thing. Our last example, Canadian house video should be 14A rating, our TVG rating system, if you will. Then 14-year, it should be older than that. That is an example of inequality in real life situation. Now, let's do some practical mathematic example. It says, given the inequality x is bigger than 3.5 or equal to 3.5, which of the following will be solution? How do you know? And the question asks to use number line. Or sometimes the textbook or assessment may ask use graph, which is basically similar as number line in this specific situation. I need to tell you about notation first. So I want you to write down two different type of notation. I want you to draw a solid circle, and I want you to put that. This, actually, there's too much of equal sign. 0. Solid circle is used when we have bigger or equal to or smaller than equal to. This is one of the rule number 1. Rule number 2 is this is first of an empty circle. Empty circle is used when we have bigger than or smaller than. I want you to pay attention to these two notation with solid circle or empty circle situation, because depends on the situation, we have to interchange the use of solid circle or empty circle. In this specific example, we have bigger or equal to, so that's a fancy way of referring that we need to use solid circle. So let's see how it use. I want you to locate 3.5 first. 3.5 is between 3 and 4, midpoint over here. Because it has a smaller and equal to, I want you to put a solid circle, and x value is anything that is bigger than 3.5. So that means, there you go. This representation is a visual way of referring x is equal to and bigger than 3.5. Anything else, I put infinity, positive infinity, that is belong to this shaded area, belong to the solution. So I can say negative 3.5 is not the solution. 8 is located in the shaded region. It is a solution. 3.5, it is solution because that is exact that dot position over there. 3 is below, so that's not a solution. 3.6 is a solution. Thus, how do we know? Well, I want you to draw the number line or graph, and whatever the answers that belong into this shaded region in your graph or number line is basically solution. So solution is no longer one type. It's going to be way more than one type. In fact, it's close to infinity, to be honest. Now, using that class example, or what we just did as a demonstration in front of you guys, let's graph each of the following. This really shouldn't take a long time. Why don't you actually pause the video, give it a shot, and double check with my answer. If you already solved it at this time, this is a good point where you can double check whether you're on the right track or not. First, I gotta zoom in. There you go. The first example, show x is bigger and equal to. So that means it's a solid circle, f3.5, which is actually turned out to be our exact same answer from previous one. So I'm going to move on. It doesn't have equal to, so it is a empty circle. It says anything that bigger than -4. Here's my possible solutions. And of course, it goes all the way to positive infinity because it's on the right side. Y is smaller than 1. It doesn't have an equal sign, so that means it's an empty circle. In this case, negative infinity, something smaller than 1. So even negative 0.9999999 is actually, sorry, not negative. Anything that is 0.99999, that can also play a huge role as a solution, if you will. K is smaller and equal to -5. The solid circle is smaller than, so negative infinity over there. E is saying -2 and bigger than. Empty circle. Bigger than means it's on the right side of the spectrum. Positive infinity. J is smaller and equal to 0. Solid circle. And anything below that. M is equal to smaller and equal to -1. That's where we can put our solution. I forgot. This is optional. You don't need to really indicate negative infinity and positive infinity, but That is just common sense at this point. K is equal and bigger than 6, so it's solid circle. There you go. X is equal to and smaller than 3. My OCD is driving me crazy. All the way to positive infinity for H, negative infinity for J. Now, I mean J. Do each of the following represent the same inequality? Justify your answer. So we have a two choice. X that is smaller than 5. So I'm just going to put 1, 2, 3, 4, 5. Actually, it says smaller and equal to. So this is my representation. The other condition, I'm going to choose red. It says smaller and equal to negative 5. Also solid. And there you go. Do each of the following represent same inequality? I like to say no. It does overlap x that is smaller and equal to negative 5, but I want you to pay attention to this green region over here. This part only belongs to the first condition, not for the second condition. So I like to say no, only negative 5. I should have said smaller and equal to, sorry. I mentioned that part though, just my normal verbal mistake. Only this region overlaps. You can put it that way. All right, this time I want you to take out a blank piece of paper, and I want you to put a title, Advanced Inequality Expressions. We are not doing equation today. We are going to do and focus on expressions only. Example number 1. What are you going to do if you have an expression where negative 5 bigger than x, smaller than positive 5, something like that? So in this situation, you have multiple constants happening. One of the first event is talking about negative 5 and x relationship. That's one. The other event is talking about x and positive 5 situation. And if you're asked to find solution that satisfy this situation, it's gonna be a little tough if you try to do everything in your head. Now, there are several ways that we can do, but one of the best way that I always suggest is number line or using the graph. Start from 0, which a lot of people do. 1, 2, 3, 4, 5, negative 5. First of all, it is not a solid circle. It has to be empty circle because it doesn't include equal to, and it says bigger than. That's my first condition. My second condition, this is the one that has a solid circle because it has equal sign and is smaller than. So that is very ugly. Let me draw it again. That is a situation. Now, this is step number 1, step number 2, which is identifying the first condition on the left, second condition on the right. Then what you need to do is find out the overlapping region. The one that negotiate both conditions. That's my number 3. And imagine this is a multiple choice situation where you need to find the solution that fit to. Let's say, in this case, A indicate negative 5, B indicate negative 7, C indicate 6, D indicate 3. The correct answer in that situation is only 1. D is equal to 3 because that is located on positive 3, which is between the first condition and second condition. Negative 5 is out because negative 5 is not considered as equal to condition in the first one. Negative 7 is beyond the first boundary. 6 is beyond the second boundary. Thus, D is the only right answer. This is one of the type. Also, We need to we need to know how to go backward. Let's say x is equal to negative 1, 2 over 3. And you have a condition where it says something like that. Actually, let me make it a little bit more tricky. In this case, what people do generally is they rearrange in an ascending order. What I mean by that is so that small number, larger number, go vice versa. Except you need to include the condition. So if you rewrite negative 2, 1 over 2, bigger and equal to x, smaller than 5, 1 over 2. Sometimes, if it's number line, even though it has a common denominator as a fraction, it is easier to make it into a decimal. So instead of 2 and 1 over 2, negative 2.5. Instead of 5 and 1 over 2, 5.5. So in that way, we can actually locate our so in that case, we can record our by the way, should be empty circle. Our one of the boundary, doesn't matter where you start. I'm starting bigger boundary this time. And small boundary. Again, order doesn't matter. As long as you know what circle you're using. Empty circle or solid circle. And the boundary is between these two. Whatever the overlapping section, if you will. Now let's justify. The question says x is equal to negative 1 and 2 over 3. Is that possible? Well, first of all, you can do several ways, but like I said, decimal actually play a huge role when it comes to number line. It just makes your life a little easier. What I am going to do is, this is traditional algebra method. If you have a calculator basically tell you, but I am changing my denominator into 9 because 6 over 9 is 0.66666 and keep going, aka it's a repeating decimal. And negative 1 is our whole number that can replace this 0. So long story short, negative 1 and 2 over 3 is negative 1.6666666, and then it kept repeating in that pattern. So now, once you identify my possible solution, you can then actually substitute this into the boundary and then see whether that works or not. It turned out it worked because it's slightly more on the left of halfway of negative 1.5. Actually forgot to put there's one more. Then in that case, this is around there. But in any case, this is how you can justify. So today, we'll learn about how inequality can be used with variable and with either one constant or another constant. All right, so today's homework will be on MathLink chapter 9.1. Chapter 9.1. I want you to go to page 300. Oh my goodness, it skipped a lot. Let me just. Of course. Ah, there you go. Page 347, 348, and 349. Fortunately, we are not learning anything that involve with equation per se. Everything is about representing. So I want you to do, let me circle. So it's actually a little pain in the butt to, there you go. I want you to do number 6, number 12, number, there you go, 15. Oh, come on, you. In any case, 15. Then when it comes to apply question, so far we have 3. 16, 17, 20. So we have 6 question. Actually, I need to give you one more. Almost forgot about it. It was good. There you go. 23. So you have the 7 question, ladies and gentlemen. Now get to work.